Okay, so let's look at the following question. Let's just work through a couple. So what we're going to ask to do is to use a Venn diagram to list the elements of each of these sets. Okay, so the first set that it asks for is the set A. The set A. Now, a thing that we can use as well is this symbol here. I'm going to just make you aware of it. So this, and this is one. So this means element. Okay. So what you could say is that, for example, you could say that, actually, I need to label these. So this is A, and then this is B. So you could say, for example, that 6 is an element of A. So that means that 6 is an element of A. So that's just a symbol that means element. It's something that's important that you need to know in relation to sets. So let's just work on this one. So what we're going to ask to do is to list all the elements in the set A. So if we were to just look at that on the Venn diagram and understand what it is, so set A is everything that's inside here. So it's all of this. So that's going to be all set A. Okay, so all the elements that are in set A, you would just list them out. So it would look something like this. So the set A is equal to, and then you just use your brackets, the elements 3, 4, 5, and 6. Okay, so really simple. So that's just all the elements. That's all the elements in A. So you could be asked for, so what are the elements of B then? Let's say if we say B. So what are the elements in B? So again, you're just going to list everything here that's in B. So let's look at that. So it's going to be everything that's within B here. Okay, so B then is going to be the elements 3, 4, 9, and 8. So 3, 4, 9, and 8. So we've listed all the elements here. So 3, 4, 9, and 8. If we were to think of A complement, so this symbol, so the elements in the set A complement. So what's A complement? So A complement really, if we were to look at it, is everything, all of the elements except the elements that are inside A. So what would A complement look like? So if we were to color this in purple, A complement is going to be everything that's inside the universe, inside here, and then also everything that's inside B, but not what's inside here. For example, everything that's inside B, but not in the intersect. So it's going to be A complement then is going to look something like this. So it's going to be, A complement is going to be 2, so the elements 2, 7, so 2 and 7, 10, 9 and 8. 9 and 8. Okay, so that's all of the elements. Everything except what's inside this circle that represents the set A. So that's A complement. If we were to think then of B complement, so B complement is going to be everything that's inside A and the universe, but excluding what's inside B. So B complement then is going to be, so it's going to be 2, 7, 10. They're inside the universe. 6 and 5. 6 and 5. Yeah. 6 and 5. So that's what's known as B complement. Then if we think about A union B, okay, so A union B, if we're to think about what that is, A union B is going to be everything that's in A, everything that's in A, and everything that's in B. So it will be A and B. It will be everything that's in both A and B. So a union, remember, just think of it looks like a U, and union means that two things are connected together or joined together. So therefore, all the elements that are in A and in B will now all be in just one set called A union B. So it's going to be 6, 5. So 6, 5, 3, 4, 9, and 8. Okay, so that's A union B. And then if we think about, so if we had something like this, A union B, and then if we put this in brackets, complement. So what's that going to be? So remember, complement means that you're excluding what's inside these sets, and then you're including everything else. So A union B complement means it's everything, let's say, everything that we have, everything that's just in the universe, except what's in the two sets A and B. So what that means is that, so A union B complement, this symbol up here, it means that you are only including what's in the universe and you're excluding what's in A union B. So it's going to be the elements 2, 7, and 10. So notice that you're excluding everything that's in here and you're including everything else. That's what this means, A union B complement. That's what complement means. Also as well, I just want to introduce this other terminology as well. So you have this thing that's called the cardinal number. So it's C-A-R-D-I-N-A-L. So cardinal number. M-E-E-R. So cardinal number, the symbol for that is this here. And what the cardinal number represents. So let's say if I wanted to know what is the cardinal number of A, that's going to be all the elements, the number of elements that are in A. So if we think about the number, we'll just underline them here. So we have 1, 2, 3, 4. So the cardinal number for A is going to be 4. If I was to say, like, what's the cardinal number for B? So the cardinal number for B is going to be all the elements that are in B. So in the set B. So there's 1, 2, 3, 4. So the cardinal number for B is 4. If I was to say, for example, what's the cardinal number for A intersect B? Okay, so remember, A intersect B, the set, so I'll just write the set here. So the set of A intersect B, remember this means intersect, is going to be equal to, it's just the numbers that are in here, the elements that are inside the intersect. It's where set A and set B cross over, and what's in that set space where they cross over, that's what's known as the intersect, and this is the symbol that we use for that. So it's going to be the elements 3 and 4. And so the cardinal number for A intersect B is going to be equal to, in this case we have two numbers, so 2. So that's what we mean by the cardinal number. It just represents the number of elements that we have in whatever particular set it's talking about. And what else? Let me just see. And I just want to introduce this last idea as well of what's known as the null set. So null set. So the null set is like, it's just an empty set. And what we do is we use the symbol. So you use this symbol. Okay, it's like a null with a line through it, or it can be like this, just so it's like this empty bracket. It's like the bracket that we use for the normal sets, but there's just nothing in it. So a null set would be, for example, an example of a null set in real life would be people over 2 inches tall. Okay, so there are no people that are 2 inches tall, so therefore this will be what's known as a null set. Okay, it's a category, but there's no elements, or there's nothing that we can put into that, for example. So that is an example of a null set. So you could say people, so, or let's say 2 centimeters tall is equal to, so that's your set, and it's empty. So this is what's known as a null set. So it's just for completeness, but who knows, there could be people 2 centimeters tall in some place in the universe that we haven't discovered. But as of now, as of what we know, this set is empty. So therefore we have this idea of what's known as the null set. So I just want to introduce that as well, and these are the symbols then that we use to do it. Okay, and then just as a reminder, so this here is what's known as a Venn diagram, and then each of these circles represents the set, and then this is how we can write out the elements that are within the set. This symbol here means an element. So for example, 6 is an element of the set A. So that's the way you would write it. 6 is an element of the set A, and we can see there that we have 6 here, and it's an element of this set A. Okay, so thank you for listening.